Hi, good afternoon. Yeah, so I was listening to Peter's session earlier on, and I could see, I was talking back, and I could see one of this scenario that he was talking about with the warehouse. It was quite an exciting experience to understand how he thinks it. And there were all the sort of nodding heads and calling out suggestions. And I think we've all been in those situations where we're not necessarily in the comfort of our house, we're on site, it's uncomfortable, it's being intrusive to the customer. It's not really a good situation to be. And the other aspect is that we've got quite a lot of finite skills, and like Pete was saying, it's sort of the art of knowing how to apply those. And this is really why we really want to discuss Wyebot, because Wyebot is really coming from that perspective of having that skill set and maybe offering it up ahead of time. And so, as an example, knowing that there's maybe Bluetooth in the facility that's causing problems, or maybe that classic one which we actually was the nut of what we were talking about was the legacy data rates. A lot of APs, I've seen a lot of different vendors, and their factory defaults leave the legacy data rates on, which is okay because it's a catch-all. But the reality is that it means those beacons are going out to those rates and they're taking up airtime. And as we know with Wi-Fi 6, it's all about airtime efficiency. So to know this kind of information, to know airtime usage on channels, to know the distribution and maybe where the band steering is working or not working, it is really a great tool. And what we've really done is try to automate that situation of the engineer on site to allow us to give us more time, because we're only human beings. We can't, when we get more maybe than 10 problems, then we sometimes get bogged down. So to try and bring that intelligence into a solution is where Wyebot began with its design. Now, one of the things about Wyebot is that we are vendor agnostic, so it doesn't really matter. The Wi-Fi is Wi-Fi 802.11 frames or 802.11 frames. We're only looking at the Mac level. A little bit about the company is that a lot of the founders of the company are coming from HPE then, but originally Clearance Networks, which is, some of you may remember, was a very common solution for hospitality, and that was acquired into HP. So that's how I knew these people. So we worked together a lot, and one of the design goals was all the effort required, the extra expense of sending people on site, the interruptions with that business, maybe a school where as soon as someone who's not a teacher walks into a classroom and tries to take packet captures or something like that, it's very disruptive. So trying to get rid of that disruption, build in some tools for analytics, but also build a solution that monitors the network constantly. And that's really where the design of Wyebot comes. I'm sure someone would ask the question of why it's called Wyebot. So it's basically built up for out of a number of different bits, bot being the sort of automation aspect of what we're doing. So let's just move on. So familiar ground. We're all quite familiar with the tools of the trade, the heat map, the schematic of the heat map. We drop the APs in there, and then we're looking at that kind of output, where it gives us confidence. It's a tool, it's mature, it's a mature type of tool to do the job. And we basically hand that over with a little bit of confidence to say, right, the APs are in the right area, signal strength is good, we should have good coverage, no problem. But of course, have we missed something here? Well, of course we missed something here, because we've not actually factored in the humans, the client devices, really, I put it on this slide to better understand. So your own clients have some airtime requirements, and are they using the airtime efficiently? You've got neighbouring networks and neighbouring clients that are sitting on the same channels that you want to run on, and they may not be configured in the correct way. So you might have trimmed off all your legacy data rates, everything's perfect. but you've got an AP that's in range, that's maybe from a company next door, and they're running the full legacy data rates. They're running an 80 megahertz wide channel. Those kind of things are going to kill your well-designed and deployed Wi-Fi network. And then things like RF interference. So we know that Bluetooth is something that operates on 2.4. It's an unlicensed channel or unlicensed band, so that's allowed. But then we can get other things like microwave ovens where the energy leaks out, or DECT phones, that kind of thing. So to understand these things, we understand that actually below the level on the iceberg, there's a lot of other things to take into account. And the last thing really is that most of the solutions we use in a working environment require the internet. So is your internet working well? Have you got good DNS? Have you got good DHCP? This was something that was highlighted in the MIST session earlier on. So these are all things that come about. I just chucked that graphic in there just to reiterate that we might have the fastest clients, but if there's a guy that's running, trying to use the connection, and he only supports 1 megabit because he's compromised on signal strength of coverage or something like that, then the fast people miss out, and then that concept of having different band widths on the channels cause problems. So, in summary, the Wi-Fi site survey, ACA-HOW, that kind of technology, very good, very solid. And what we would say is to keep that concept, that quality, is that you need to really carry on monitoring the network and actually be an end device. And this is what Wyebot does. It's we have a solution. It's effectively an overlay solution. So we have a hardware piece which is a sensor. It's equipped with 3 Wi-Fi radios. And so in terms of outcomes with our solution, we can ensure that the users on the network, the people that phone us up and complain or have trouble tickets, they can have a good experience, because the Wyebot solution is constantly checking and testing the network in various forms and the various applications that are business critical, like Office 365 or Google Workspace, that kind of thing. And another aspect which goes back to the session earlier on with the warehouse, we're potentially reducing customer site visits. Okay, the sensor will be able to maybe speed up your requirements to do troubleshooting without the need to jump in your car or jump in a plane and go out to site and hence have that problems of maybe access to the site, etc. And how do we do this? We're doing it because we're constantly monitoring the Wi-Fi network. We have the sensor is able to monitor the 2.4 and the 5 gig spectrum. We're able to test the network as well. So because we're a client, we connect to a particular SSID. We would then run a test. Maybe it's a speed test going out to the internet and back and forth, up and down, or it could be iPerf, or it could be simulating voice or video traffic. And we could do that on the Wi-Fi and the wired. So, one of those reference points is does it work on the wired network? It must be the access point. So, by collecting that information and keeping it a tally of how the system performs over wired and Wi-Fi for the tests that we're running is how we do that. And understanding the effect of the neighbouring Wi-Fi. So one of our design goals is not necessarily to make it a system that looks overwhelming or looks a little bit scary. It's really generalised for different types of levels of knowledge. Fundamentally, we're trying to make a solution that is proactive, where maybe someone just wants the helicopter view of everything is good or not good, and then the sort of help desk network engineer who maybe knows networking but doesn't know Wi-Fi, with our feature set, we're able to allow this guy to be proactive and understanding what's going on in the network. And then we also embed tools into our solution. So we have packet capture capability, spectrum analysis. We call this device forensics. That allows us to look closer into the client. We store this data for a full 30 days, so we can go back in time. Because one of the things in life is that someone complains, and eventually someone in the organisation says, oh, okay, I understand you had a problem. Yeah, that was last week, it's working now. So by having that historic data, you can go back in time. So you can say, okay, let's wind back the clock, let's have a look. And we can do that with our insights and also with packet capture as well. So one of the aspects of the way we do packet capture is we're constantly writing the packet headers, not the data portion, but the packet headers into memory. And you can recall that information, so you can go back in time, 24 hours as a minimum, and pull back that packet capture. It could be on a unique channel, or it could be time slicing going through every channel. So what we have is a cloud-based dashboard. So this is one level down. So we're looking at one of the sensors. And in here you can see that we have a panel here called issue detail. So what that's doing is it's understanding and observing the behavior of what's going on in the air. So as an example here, we categorize them with critical, major and minor. Critical being something that really eats up airtime, like multicast traffic. Multicast traffic just goes everywhere. It's not really ideal for Wi-Fi, and a lot of vendors put configuration in on the Wi-Fi to allow the best handling of that. So we have a couple of examples here with legacy data rates being observed, or maybe APs on similar channels causing us problems. Or the other classic one, which we often find, is that people love to have an SSID for absolutely everything. And as we all know, there's a tipping point of too many SSIDs mean that your airtime is consumed just by advertising your networks, and the data really doesn't get any time on there. And then another aspect here, as an example, would be to observe the fact that maybe we have an AP that's in range of the sensor that's operating on a non-typical channel. So channel 5, I've seen this with some of the sort of commercial devices where they'll even have the cheek to bond two 2.4 channels together, which is not at all good in our world. So here is just a couple of quick screenshots of an example. So this is a network test. Our tests are automated and repeated, so every 20 minutes our sensor is connecting to a particular SSID, and it's going out, it's measuring the URLs needed for Office 365, and it's reporting the results back. We can set it up so if the test fails, so if one of these URLs doesn't come back, so we don't get an HTTP 200, then the system would send you an email to say that test failed, here's the date and timestamp, and which particular sensor was failing on it. So let's move into the components. So this is just putting it into perspective. So here's our hardware sensor. The scale is not true, so it's not that big. It's more like an AP. It just needs has an RJ45, and it's just looking for PoE. If you get a PoE plus, that's no problem either. But what I wanted to say is that in the hardware itself, we've got 3 Wi-Fi radios. We've got 2 monitoring radios, so they're just listening. We're not advertising or not making any frames out. They're just listening to what goes on the air. This is how we build the understanding of what's going on, whether there's legacy data rates or whether there's neighborhood issues with other APs on different channels. And we have this radio here is a multi-personality radio. So this is responsible for understanding, it works with the other 2 radios to understand what SSIDs are in the air, but also its primary job is to be a client on the network. And that's really one of the big things for me, is the fact that we have Wi-Fi and APs, and you can configure them perfectly, but the reality is that as soon as a client device is getting involved, it really does that's where you get into the Wild West, because not all clients behave the same. The guy from Mistwood picked up on the fact that even 2 iPhone 12s won't behave the same. So it really comes down to client behavior. So to be a client monitoring your network, and regardless of which vendor you're going with, we're just joining the network on a particular SSID, whichever you want, whichever you plan to track, and then performing network tests. But also we have a backhaul, so this sensor needs to send its telemetry back to the cloud, and we do this on a backhaul wire port. But we also use this port to do network testing. And then I put down here, we got the packet capture capability. As I say, it's a memory ring buffer in there that's constantly running and writing the packet headers into the memory there. And then on the left-hand side here, this is just to go back onto the dashboard. You saw a quick screenshot of it earlier. We don't have any restrictions on login. We have historic data, so we've got full 30 days to go back. We have an API, so you can extract the information directly in a JSON format and take it to another dashboard of your needs. So one of the other design goals that we put in was the fact that the dashboard really needs to be the best place and the place where you have all your information. So one of those aspects means that we put our release notes in the dashboard, so you don't have to go off to a particular support website / whatever and looking at the release notes. We have documentation in the form of a knowledge base article in the top right-hand corner of the GUI, and then we have context-sensitive help. And in the middle here, this little icon here is feature requests. Now, this allows us to keep up with our customers because some people will make good suggestions actually beyond what we were expecting, or maybe they might be in line with what we were considering to put on the roadmap. So this is a very good way to stay in touch with your customers. So rather than the message being diluted as it comes up from the reseller and like Chinese whispers effect. So just a little bit more about the detail of the sensor. As I said, 3 Wi-Fi radios. The multi-personality radio is involved primarily with network testing, but also it's used to scan channels around to work out where the APs are in range. And then we can make a decision on which channels we need to monitor with the passive radios. We are very much into plug and play. So a lot of people use that phrase, it's like a throwaway comment, plug and play. But actually one of the comments we get back from our customers is that as long as you put the sensor into an internet-enabled port, it will find the cloud. And that's one of the aspects where there's no need to install an app to then bring it online or anything like that. So for me, that's a real positive point, is that it's very easy to deploy. Like with the 2 passive radios, they would typically want to monitor one on the 2.4 and one on the 5 gig spectrum. However, you can configure them to put them both on 5 gig or both on 2.4. It really comes down to what you need. Because they're not transmitting, there's no problems with interference between the 2 radios. So let's move on to the types of network tests that we can do. So we do automated tests. They're run every 20 minutes typically. Some of the tests have a slightly longer time between repeat times, partly because if you use speed test, if you try and do that every 20 minutes, sometimes your ISP has the ability to actually slow you down rather than speed you up. So this particular test is one where we do it every 4 hours. We have video and voice simulation, so we're able to simulate that traffic. We have a test here called DNS performance. Now this one's a really interesting one because when people deploy networks, they normally say, okay, this is a fairly high-end network. We need multiple DHCP and DNS servers because we need resilience. And that's fine. And what happens is the client device will get a resolution from one of the DHCP, so one of the DNS servers. But of course, that's a bit of a perfect storm, really, because the user of that device will never realize or complain if the primary DNS server had gone offline, because it's still able to get URL resolution and get out surfing into the internet. So with this particular test, what the sensor does, it goes on to whichever Wi-Fi network you wanted it to go on, or on the wired network, and it will get an IP address for that particular test session, And the DHCP options will include maybe an array of DNS servers. So what the sensor will do is it will check a resolution on a given list of hosts on each DNS server. So if there's 3 DNS servers, it will try and check that it can resolve maybe facebook.com on all 3 of them. And then it will go to another host, and it will basically resolve about 5 hosts on each DNS server. If one of those DNS servers times out, that is classified as a failed test, because rather than lead you astray, we're actually identifying that there is a potential problem coming. And this is what I think the Juniper Mist guy was talking about, is identifying perhaps problems that are about to happen, and being aware of them. I've put a couple of little arrows here because you can actually set the thresholds for pass and fail, because not everybody has the best internet service provision, me being one of them. I live in a rural area, and I get really annoyed when people say I've got 20 meg download. I struggle with that kind of figure. So we can adjust these thresholds for DNS, for speed test to do up and down, download tests, to make it, to give no situation where you've got false positives. So let's just move further on. Now, in terms of some of the where you want to take it a bit further, so ultimately a lot of us end up doing troubleshooting. So we do have some advanced capabilities. I talked about packet capture, the customized network test. Now, what I mean with that is that as a client device, we join the network, and any client will probe for the beacons that it wants to connect to, and then the APs respond. And then based on the quality of the connection, it will choose a particular AP. That's classic. That's the way most clients work. We can actually override that in Wyebot. So we can say, no, I don't want to test with that AP that's the closest. I actually want to make it more challenging, to maybe go to a specific AP that's not necessarily in range, or maybe a group of APs. So do the same test on a group of APs that are not necessarily the strongest connection. Or maybe we can restrict it, and we only want to do this test on 5 gig, or maybe we want to do it on 2.4. So we can customize the way we behave as a client. We have spectrum analysis on board, so we're using those 2 passive radios from Broadcom. The Broadcom have embedded spectrum analysis capability in there, so we just extract that. We have a feature called AP classification, which is when the system first comes up, it will scan around and it will find your APs, because you've already told the system these are the SSIDs that I'm running, and this is a username and password or appreciate key for getting onto these networks. So what happens is they are identified as your own network, and everything else is unclassified. You have the option then to go in and say, well, that's my neighbor, I can't get away from that. But by using AP classification, you're able to filter them in or out of view, so you can understand the effect of maybe your APs look really good on their own, but when you take the filter off and you look at all the APs, including your neighbors, now suddenly you realise the channel interference, that kind of thing. And then device forensics is a way of taking a deeper look into a client, because all the time the Wyebot sensor is just looking at MAC level. We'll see clients out in the network, and because we're able to store the data, we can look at a particular client. Maybe we know its MAC address, or maybe we'll see it in one of the areas where we're looking at maybe band steering. We see that client, we can drill down on that client to understand maybe they've got a history, so go back in maybe last week, last month, to have a look to see whether they've got any problems. Also to understand their technology. We can do device forensics on APs, because a lot of APs, or some people will try and hide their SSID. That's an old trick, but of course, as soon as a client connects to a hidden SSID, there's an exchange of frames, and then the real SSID name is exposed. So what we would do is we'll still show that as a hidden SSID, but we'll put in the name. But until we learn the SSID, then it remains hidden. So let's just, this is just the screenshot showing you through the advanced menu. You click on Start Download, and then you're able to pick up the packet capture. This particular one's been taken from these multi-channels, and you can take the packet capture in the past. And then once you see download, what's happened there is that the packet contents have been sent up to the dashboard. We don't filter on the packets, we don't trigger on the packets, we're capturing all the time. So we've, again, a bit like this, we come from it from a slightly different angle, saying, let's let the person looking at the packet capture put the display filters on, let's not take anything out. We don't look at the payload, so we're only getting the clear text packets. This is something I just talked about earlier on, in that we can make our sensor connect as a client using multiple APs or a specific band or a specific AP. Now, this is just an example of how we would do that. So this is, okay, we just have to have some Meraki APs in our lab. There's no affiliation here. So we set up a Meraki AP with WPA2. So this is the SSID, we called it so we can identify it quickly. So what we're doing here is we're creating a network test. It's called Link Doctor. So we've trademarked that name because Link Doctor is about connectivity. It's basically trying to simulate what most of us want to do when we're shown a problem with Wi-Fi. We want to get our own laptop, we want to connect to that network, we want to do ping and such like that. And this is what Link Doctor will do. It will go out and it will ping the default gateway, it will ping the DNS server, and then it will go out to the internet and try and ping which is Google's DNS server. But this is an example where we've told this particular test that we don't want to check the closest AP. We actually want to test multiple APs, and actually there's the 6 APs that are in range, and we're going to do them on both channels. And then we can say, if we have multiple sensors, maybe we want to only run that test on one of the sensors, or we want to run it on all of them. So we have a degree of flexibility in the way we do it. This was just an example again. So you saw a small screenshot earlier. This is our spectrum analysis. So as an example here, so a lot of us are familiar with the waterfall diagram and that sort of thing from Insider. When we were thinking about how we wanted to do spectrum analysis, we decided, well, the audience that we're trying to design the dashboard for may not be familiar with those kind of tools. It could be a pair of eyes that know networking, but they don't understand Wi-Fi tools. So we decided to simplify the effect by just having a graph that basically goes up to a count of 1, and then we identify the problem. So we've got a signature here that's been triggered, including how much of channel utilization it caused and what channel was affected. Again, here's an example of a microwave oven. Not a technical tool, but they do generate noise, and then Bluetooth, narrowband jamming, that kind of thing. So that one of the aspects of Wyebot was to present the information, perhaps not necessarily in a too scary technical way, but that leaves it open for Wyebot to also maybe complement what a lot of the specialists that are here do, which is, before they want to go to site, maybe they want to understand how efficient the Wi-Fi network is. So by shipping a sensor out and getting them to connect, you don't even need to leave your office, but you now understand their SSIDs. You can test their network, so maybe they're people that are having problems with Teams, so you can set up a video conferencing test to run Teams. And that's all done remotely. You didn't need to go to site. It's not disruptive at all. Now, I don't know, I've probably coming towards the end, but then again, I don't want to wrap it on too long. But if you wanted to know more, then we have a YouTube channel. Our documentation is available to you, and also we got some training videos, so some of the feature sets, how you would go about and implement them and what they're telling you. So, I've basically finished. Are there any questions? Yes, please.
if you want to use the Wyebot sensor as acting as a wireless client, what is your recommendation on installing? Where do you put the sensor?
Right, that's a good question. It really depends on what the sensitivity of your situation is. So if maybe you have a remote office, you have a handful of employees there, you don't necessarily need to deploy multiple sensors. One sensor could be enough because that sensor is, one, able to monitor the airways, and two, do the network testing. So you know when you've made that decision that all the facilities they need, maybe they're going out to Google Mail or something like that, can be tested by the Wyebot sensor. So it comes down to that. If it's more of a critical situation, so maybe you're a hotel, you have a conferencing area, obviously people that turn up to a conference a bit like this here, we're quite demanding on our Wi-Fi, so you might need multiple sensors in that particular situation.
I was also referring to the mounting. Is it on the ceiling or on a...
Typically, we would just go on a ceiling with the ceiling tiles and brackets. Basically the same philosophy as an AP. The only thing to recall is not to put it right on top of the AP. We need to be a particular distance away, like a client would be. Yeah.
Can you also do application performance testing? So simulate application by log in to certain sites and let's say opening menus. Or
like click here, click there.
Yeah.
It's something that we're considering. I know that one of our competitors at Aruba UXI does that. So I think that's where the question came from. And I think that it's under consideration. I think that there's a bespoke requirement for that, but not necessarily as maybe as important as some of the other stuff that we're doing on the roadmap. Things like SAML, we've got single sign-on. So rather than username and password when you log onto the dashboard, you can use your Azure credentials or Google credentials. So we've got that capability. So there's certain things, like every small company, we've got a roadmap, we've got requirements, and we've got an engineering team that's a finite size. So, but one of the other things that we've just done, if you read the press, Intel have made an announcement. They've named Cisco, Wyebot, and there was one other, I can't remember their name. We've got we've done some partnership with Intel. So any device with an Intel chipset has a small piece of code embedded in the hardware that Wyebot can take advantage of, which means that we can now put a small agent on the client, and that's going to work more effectively than maybe putting a user space agent, because we're tied into that hardware. So that's something new coming along, and that's where our engineering resources focus. Anything else? Oh, yeah.
Meant for permanent scanning, like you put it up the ceiling, you leave it there for months or years, so it's more for consultants to troubleshoot.
It really comes down to the requirement. Ideally, we would like a permanent deployment, because then you're getting good assurance that your network is working. However, if you're maybe you, as an NSP or as a consultant, you may have a customer that says, oh, I want an extra bit of service, and you could use Wyebot. You would be our Wyebot customer, and then you would deploy the sensors out. And we do have people doing that, yeah. Anything else? Good, right.